Greaco Latin Square design. This is a technical example for whatever we discussed on our previous video. So please, if you haven't watched that video, kindly go back and then watch before you start with us with the example. So let's go through the example, and after that we will solve it using the formulas. So it says the yield of a chemical process was measured using 5 batches of raw materials, 5 reagent concentrations, 5 standard times, 5 at catalyst concentration. The Greaco Latin Square that follows was used. Analyze the data from this experiment and draw conclusions. So we are using an alpha of what? 0.05. So this is the question, and this is what our design. So let's kindly go to our worksheet so that we will solve it and solve it very well there for you guys to really understand it. So this is the worksheet, right? But before we do any calculations, I want us to go through this before we do any calculations at all that we want to do, because once we understand it, it will be very, very simple for us to do the rest. So we have what we call the batches here, right? And then we have the batches here, and then we have the reagent concentration, right? They are both the Latin and the Greek letters that we find. So we have A alpha, right, which is 22, 16, 19, 16 and 12, and then 22, 18, 24, 15 and then 10. So what we do is that we have to just add the value for all the columns that we have. So 22 plus 18 plus 24 plus 15 plus 10 will give us 89. Then 16 plus 21, 12, 15 and 25 will give us 89. So we just add all the columns, right? The value for all the columns. Once you do that, we are going to get these values here. And then after that, we just add all the rows. So 22 plus 16 plus 19 plus 16 plus 12. We are going to get 85. 18 plus 21 plus 14 plus 15 plus 10, we are going to get 87. And then 24 plus 12 plus 17 plus 25 plus 30, which is 91. And then the rest, right? I want to just add all the rows as you can see here. So after that, we just use this strategy to check if all your inputs are correct, right? All your additions are correct. So just add all the rows that we have here, the rows, this is the numbers that we have here, and the column number that we have down here. So both of these number must yield 433. If once both this one and this one yield 433, then you can go ahead and do your calculations, right? So that is for the rows and the columns, right? So let's come to the Latin square, the Latin letters and the Greek letters. So since you are going to calculate for sum of square rows, that's the reason why we have added all the rows and the columns. We're going to calculate for sum of square rows and columns. We're also going to calculate for sum of square for the Latin and then the Greek, right? So here, when you come to the table, when you see that A is repeating in each one treatment, right? So once you pick A, you go to the table and then pick that individual values in the treatment that is associated with A. When you come here, you have 22 for the A for the first column. We have 25 for the second column. We have 22 for the third column. We have 25 for the fourth column, and then 90 for the last column. So once you add this, you are going to get 130, right? We're going to do same for the B, right? So once you come here to, we have 18, right? For the B, we have 16, we have 16 again, right? We have 18, we have 16 again, as you can see here. Then we have 14, as you can see here, and then 13. Once you have this, then we add everything. So we are going to do for the C, right? We are going to do for the D, and we are going to do same for the E, right? So when we come to the Greek letters too, once you take alpha, right, it also works the same thing. So alpha is 22. When we come here, alpha, we have this alpha plus 12. We have this alpha plus 16. We have this alpha plus 15, and then we have this alpha plus 17. So we are just going to add them, right? So once you take the letter, just go to this thing, each column, and then pick the value and then add them, right? So after we have the addition of the Greek letters and then Latin letters, and then addition of both the rows and the column, then let's come back to the main business, right? So here we are going to calculate for our sum of square for the Latin, and the sum of square for the Greek, sum of square total, sum of square rules, and what the sum of square column. Then use this one to form our analysis of variance table. So at the end of the day, we saw that during our previous videos, we made a videos on the meaning of the y dot 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 k dot, right, and then y dot 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 dot, right. We just so if you haven't watched it, kindly go back and then watch that video, because it will help you to really understand whatever we are coming to do today, right. So at the end of the day, let's start from here. So this is the sum of the SSL is what the sum of square for what the Latin square, for the Latin letters. So the formula is 1 over p, right, 1 over p summation of y subscript dot j dot dot square, right. So the summation of the y dot j dot dot square means that we are just going to take the individual summation of the letters and then just score it, right. So here our p is what the dimension for, I mean the Latin square design. So here our dimension was what 5 by 5 what matrix. So here 5 by 5 Greaco Latin square design. So here we will have 1 over what 5, since the p represent what the dimension of what the matrix, right, more or less. Yes, that's the dimension of the matrix. So here we have 1 over what 5 summation of what the individual Latin letters that we sum, right. So when we come here, we're just going to pick 113 and square, 77 and square, 98 and square, 76 and square, and then 69 and then square, right. So just 1 over 5, this all squared, right, as you have it, minus the y dot 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 is what the total of all the observation here. Once you add all the observation, you are going to get 433, right. So that one will be 433, and then our n, our big n is what 25. Since when we count this one, I'm going to get 25. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25, right. So our n is what 25, as you can see. So when we come here will be 25, right. So just punch this one, the whole of this expression, on the calculator. Once you point the whole of this one on the calculator, you are going to get this answer, this as what your final result, right. So let's do same for the sum of square what for the Greek. So here will be 1 over p summation of y dot 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 k all square dot minus y dot 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 all square divided by n. So here too, here will be 1 over 5, since the p is what for the dimension of what the matrix, right. And then this place too will be summation of what the individual Greek letters that we have, right, all squared. So at the end of the day, when you take alpha, the summation was 82. When you take the summation of what 84, when you took the summation of what 19, when you took the summation of what 82, and when you took the summation of what 89, we are just going to take it and then just put it inside and then just square, right, minus what the same thing that we had. Once you point all these things, right, and then you point this on the calculator, you are going to get 28.6 what 4 for the SSG for the Latin square design. This is what we had. And then we have a sum of square total, right. Since I said our concentration was on 4 factors, right, for the summation for the sum of square total, we are going to have 4 separate what summation, of which it's representing the summation for the rows, summation for the columns, summation for the Latin square, and a summation for what the Greek letter, the Greek right letters. So at the end of the day, we have this one here. Once you have the summation, then y subscript ijkl all squared means that we are going to take the individual observation here, right. So when you pick 22, you square, 16 you square, 19 you square, 16 you square, 12 you square. As you have squared, then we add 18 you square, 21 you square, 14 you square, 15 you square, 19 you square. So we are going to take all the observation here and then square them, right, and then add, right. So that is what we did here nicely, and then just add and subtract 433 all square divided by our 25. So when you punch everything on the calculator, you're going to get 401.44, right. So that is how we will get our sum of square what total. So take your time and use your calculator to punch. I'm going to get whatever I'm getting here as what my answer. So also we have another this thing there. We have sum of square rules. right? So that's the reason when we started, I told you guys to add the rows and columns so that when you get here, you are not going to find yourself wanting, right? So here too will be 1 over what 5, as you can see here, summation of what y subscript I dot 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 all squared. It means that they are going to take the individual summation for the rows and then just square them. So when you come here, 85, 87, 91, 83, and then 87. So once you take them, 1 over 5 into bracket of that all square minus the same thing here. Once you point everything on the calculator, you're going to get 7.04, right? And then we have our sum of square column, right? So for the sum of square column 2 will be 1 over p summation of y square dot 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 dot, dot l. So that I'm going to take the individual columns here and then do it, pay justice to that, right? 89 square, 88, 87, and then 80, right? Nicely, as you can see here, that's the same thing that you can see here, right? So after everything, you just point all of these things in the calculator. You're going to get your final answer to be 11.44, right? So whatever we have calculated down here, we just want to illustrate it on a table so that everything will be nice for us, right? So at the end of the day, we have source of variation, that's the sum of square, that's what the sum of square Latin, sum of square Greek, sum of square row, sum of square column, SSE, and what SST, right? So that's the individual respective variable that we get for the sum of squares, right? For the Latin, for the row, for the Greek, and the column, right? So we also have a degrees of freedom, and we learned that the degrees of freedom for the SSL is what? P minus 1. The degrees of freedom for the Greek is what? P minus 1. The degrees of freedom for the row is P minus 1. The degrees of freedom for the column 2 is what? 4, right? As you can see there, right? So at the end of the day, if you want to calculate for the mean square, we are just going to take, we are going to divide the degrees of, we are going to divide the sum of square by the degrees of freedom. So once you divide the sum of square by the degrees of freedom, these are the respective variable number that you are going to get. But we are interested in the f. We are not interested in what? The sum of squares, right? So if we are really interested in the f, right, we are going to get f statistics, right? We are getting f statistics for what? Our Latin letter, and f statistics for what? Our Greek letter, right? So here what it does is that we just pick the ms for what? The Latin, and then divide it by the standard error. You pick the ms for the Greek and divide it by the standard error. So once you divide, you are going to get a nice f statistics here, right? F statistics, nice f statistics. So if we want to make conclusions on this our output, what I will recommend for you is that we have to set our hypothesis, right? Before we make our conclusion, we have to set our hypothesis. So our hypothesis, we are making our conclusion on what? The Latin square design, right? And we are making our conclusion on the Latin letters, right? So here we are going to just say h naught is equal to u subscript a is equal to u subscript b is equal to a subscript c is equal to a subscript d is equal to u subscript e, right? So at the end of the day, we have this one, right? And then the alternative will be the other way around, right? At an alpha of 0.105, right? But we have to get our critical value from our table, right? So before we get our critical value from the table, here's the formula that we use to get our critical value from the table, right? So we have f subscript alpha p minus 1, and our p minus 3. So we just substituting the p. The p is 5. Once you do the substitution, I'm going to get this one, right? F alpha of 0.05, 4, 8. And so once we have this one and go to once we have this one and go to the f table, we are going to get our critical value, and after getting our critical value, we can make conclusion on that. So after having this one, you just what you do is that you just go to the f distribution table, locate 0.05, and this one is for the row, that's the 4 is for the row, and the 8 is for the column. So once you read, you are going to get a critical value of 3.84, right? So 3.84, and then for the Latin 2 we had 6.2323, right? So we are going to draw conclusion using this one. So at the end of the day, we are going to say that our f, or the test statistics, is what? Equal to 6.2323, is what? Greater than what? The critical value for that. Then we